Hello everyone, welcome back in the course of Higher Surveying, and today we are in the new module, Hydrographic Survey. This is module 9 or second last module of the course. So why do you want to learn the Hydrographic Survey? First of all, I would like to tell you, you might have heard two terms, Hydrographic Survey and Bathymetric Survey. In case of Hydrographic Survey, we collect the information of the seabed or the topography underwater surface. So we are collecting 3D information for that surface which is under the water. At the same time, if I collect some additional information, for example, the type of vegetation on the seabed or the material available or any other information which is relevant to geophysical survey or which is relevant to any other aspect of our exploration, we call it bathymetric survey. So bathymetric survey contains the hydrographic survey also. So in this course, this module is about only hydrographic surveys. You might be surprised that why do we need the hydrographic survey, where we collect the 3D information on the surface of the seabed which is under the water. Let me tell you one simple example. We are talking about the river navigation because most of the settlements and the cities are developed on the banks of the river. For example, Ganga, Brahmaputra or Yamuna. Krishna and Godavari are also good example in South India. Now we want to look for methods where we can use the rivers to transport some material. For that purpose, I need to have some place what we call as jetty or the bank where a ship can be parked or a river vessel can be parked or boat can be parked, and from that place it will start rowing in the river and it needs to navigate through the path which has enough depth of water to support the buoyancy of the vessel, and that's the reason we are looking for 3D surface data of the riverbed or seabed. A similar example is good enough to explain why do we need the seabed 3D data, because we want to navigate from one country to another country or maybe one sea coast to another sea coast across the ocean. Well, it is very much important because it will allow us to transport a heavy material using vessels or ships. I think that is a good reason to understand that we need the hydrographic surveys. So this lecture is based on the fundamental concepts of hydrographic survey. Moreover, so we have total 3 lectures in this module on hydrographic survey. First lecture is about fundamental concepts of hydrographic survey, which we are going to address today. These are the books. Few of the books are very expensive, so once you join some library or institute library to avail such books and make the notes. But again I say that these 3 lectures of this module are sufficient enough to create good knowledge. However, if you need more knowledge, you should refer these books. So let me introduce hydrographic survey formally. It is the branch of surveying which deals with any body of still or running water such as lake, harbor, stream or river, or you can also include sea. So then it is the science of study of underwater topography. In hydrographic survey, we map the features like shape of the coastline. We also find out what are the locations of possible obstructions and the physical features of water bodies, and then we try to map the shape of the sea floor. The purpose of doing this is we want to ensure safe and efficient movement of offshore transportation system. Now you may be a little surprised that why do we want to do the measurement of the complete river or complete seabed. So let me explain you the reason. You might have heard that there is a tide in the sea, and it is because of the interaction of Earth's surface with moon and sun. That's the kind of understanding we have already developed from our 6th or 7th standard. Because of the tide, what happens? Water level rises, and because of that there is a change in the water level. Moreover, such tide also creates some change in the shape of the underwater bodies. For example, there is some unconsolidated material located in the sea that will be shifted because of water level rise or maybe the lowering of the water level. We need to understand that if water level is high, how can we take advantage of that? At the same time, if water level is low, we should suspend some of the activities. But for suspending some of the activities like shipping or rowing a boat, we should know what is the water depth available at low tide. Now you got the idea that why do we need the hydrographic survey and what should be the time interval. So we should do it very frequently or less frequently or at yearly basis. So let us try to understand the fundamental concept that why do we experience the tides. We are showing 3 planets, Sun, Moon and Earth. So Earth is shown with this radius RE. Because of the attraction force between Moon and Earth and between Sun and Earth, we have tides. So let us try to understand what does it mean. So let us say this is the distance between Sun and Earth, and this is the distance between Moon and Earth. These distances are indicated by ds and dm. At the center point of Earth, the force that is acting between Moon and Earth I can write by the Newton's law of gravitation. So let us say mass of the Moon and then mass of the Earth divided by dm square. Here we are talking about a unit mass on the Earth, then I can write the acceleration at the center of the Earth as gmm divided by dm square. In a similar fashion, I can write the acceleration for the Sun at the center of the Earth, acceleration caused by the mass of the Sun. We agree with this idea? You can observe very easily, if I talk about the Sun and if I talk about the Moon and Earth interaction, there is a point here and there is a point here. This point, for example, if I call it point number 1, it is called sublunar point. Corresponding to this sublunar point, this point which is opposite by 180 degree longitude, it is antipode or antipodal point. Now you can see that point 1 is much closer to the Moon compared to the point 2, which is farthest from the Moon. And if I say there is a center C here, compared to the center, the point 1 should have higher acceleration and point 2 should have lower acceleration. So can I write the acceleration at point 1, which is sublunar point, as gmm divided by dm, which is center to center distance, minus radius of the Earth square. I hope you agree with that. And similarly, I can write here A2 is equal to gmm divided by dm plus re square. I hope you agree with these two formulas. Similarly, I can write the same formulas like A1 and A2. So if I declare that this point is point number 1 dash and call it the point 2 dash here. 1 dash is subsolar point here, and the antipodal point, that is 2 dash, corresponding to this subsolar point. Let us write A1 dash equal to g m of Sun and then ds minus re square, and similarly if I write A2 dash equal to gm mass of Sun, then ds plus re square, like this. So we know that these are the acceleration values A1, A2, and they are the vectors also. They are basically working on the different points on the surface of the Earth. What is the conclusion here? If I try to draw these acceleration values of AC, then AC will be towards the Moon like this at each and every point, because Earth is point mass. So the acceleration AC is same at each and every point as if Earth is a point mass. So here at point 1, this is AC and this is A1. Similarly, at any other point I can mark this direction towards the Moon. That means this is AC here, and if I draw the direction towards the Moon, this is A1. So basically this is direction now. So we know that there are some differential forces are acting on the surface of Earth. One, because of the center to center distance between Moon and Earth, and another is on the surface of the Earth because of the Moon gravitation. That means there are two forces working on the surface of the Earth. One is because of the gravity of the Earth and one is because of the gravity of the Moon. Now, what is the consequence of that? Let me tell you one thing, that same thing is happening for Sun also. Since I am not marking it here, it does not mean that it's not happening. It is happening with Sun and Earth interaction also. That means a point on the surface of the Earth is attracted by Sun, as well as it is also attracted by the gravity of the Earth. So let us go ahead with this idea. So this is a given situation. Now for the Moon, find out what is the differential force at a point. So A1 minus AC at this point, and what about this point? So it is GMM 1 upon d S minus R E square minus 1 upon d, it should be dm square. Now you can find out that if you take the multiplication and everything, you will get expression where dm cube will be there, and this is the expression you will get. At the same time, if you take A2 minus AC for the Moon only, again you can write GMM then 1 upon dm plus RE whole square minus 1 upon dm square. So here we will get minus 2 times GMM RE divided by dm cube here. The similar relationship I can also write for the Sun, where this mass will be replaced by the mass of the Sun and this distance will be replaced by the ds. Here we have taken one approximation that the ratio of radius of Earth to the distance dm is approximately 0, and try to derive this one yourself, you will get this one. Similarly, here if we derive such formulas, we have to take an assumption that the ratio of radius of Earth to the distance between Sun and Earth center is approximately 0, because radius of Earth is very small compared to this distance, and similarly here also. Now what are the forces for tide generation? How tide is generated? Imagine that there are some forces on the surface of Earth, say because of the Moon. So here there is a force working like AC at each and every point, and at the same time if there is a Moon here, then what will happen? There will force AC, that is because of the gravity, the interaction between Moon and the Earth. So this is center C, but at the same time there is another force working here called A1, or I call it AM now. So direction of AM at each point is towards the Moon. So like this, and like this. What about the AC? AC is like this. Here at this point, if I draw, AC is like this and this is AM, and so on and so forth. Now here AM will be like this. So you can see here AC and AM is this one. So this is AC. The direction vectors are not showing in proportion to the force value. Now if I make vector sum, I can see here that at point one is AC here and there is one AM here. So the resultant force is higher force. If I consider the top half, let us say it is equator and Moon is like this. This is resulting force called FD, or the acceleration is AD here. Now you can understand that this force is vector sum of two forces working here. So this force is causing the tide. How? We will see now. If I resolve this force FD, which is working in this direction, into the horizontal and vertical component. So vertical component will be like this, which is perpendicular to the surface of Earth, and one force will be like this, which is tangential to the surface of the Earth at this point, like this. This is FH. So the importance of this FH and FV is very critical if I want to understand the tides. First of all, we should understand that at this point this is gravity direction and force is working like this. What about this force? And this force FH is called traction force. or tractive force. So that differential force is at the subsolar point and closer to the sun, and similarly away from the sun, antipodal point. These are the acceleration acting here. Similarly for the moon, we have written like this. So you can check yourself these derivations. We have said that there is a tractive force working on the surface of the earth. What is this tractive force? The vertical force which is working perpendicular to the surface of earth at that point is not going to cause any tide. It can change something, but it is not going to cause any tide. Now, if you look at the forces which are horizontal or which are tangential to the surface of the earth on water, they will bring the water like this, because this is the force. Suppose this is the moon here on this direction. What will happen? This is the horizontal force here. This is the horizontal force here. This is horizontal force here and horizontal force here. So we have resolved this Fd into two values. Here this Fd, this force, and we have resolved it. And here there is only Fd working in this direction. Here Fd. So now you see there is Fd here. This force we have resolved into two forces. One is Fh and one is Fv. So you can see here that the half part of the earth where water is located, the tractive force or the F horizontal, it is bringing the water towards the one point which is closer to the moon. I hope you agree with that. And in order to make the equilibrium again on the surface of earth, what is happening? The 50% of the water in the other part which is opposite to the moon, it is going in other direction. So there is a point which is closer to the moon and there is a point which is exactly opposite to the moon on the surface of earth. So water is accumulating at 2 points. You can see here that tractive forces are bringing the water here, and as a result what happens, because of these tractive forces, sea level will experience a rise in the water level, because water is brought from the other places to one place. So this kind of tides are happening here, and water level is rising at this point, which is very close to the moon, or which is located towards the moon at this moment. What about this point? Here you can also see that if I divide in half, this part is also making these horizontal forces, and this is also creating a tide, or again the rise in the water level of the sea, or any river also, because if river is quite big, that will also be affected by the moon. Now you can see very wonderful phenomena here, that is on the 2 points on the surface of earth, tides are occurring and high tides are occurring. So one point on the surface of earth which is very close to the moon or towards the moon, and one point which is exactly opposite of first point. So one is sublunar point and another is antipodal point. Similar thing happen with the sun also, but small critical analysis has to be done. Water is accumulating over this place, and because of that both these places are experiencing the tides because of the presence of moon or maybe some other planet like sun. But as I told, we have to see now that which force is stronger, that means the force of the moon or force of the sun. So let us look into this. Moreover, we can see here that tractive force is although 0 at the antipodal and sublunar points, but they are responsible for creating the tides, because water is accumulated although force is 0. What should be the height of the water rise? The water rises to a level where the force of the moon on the water and the force of the gravity of earth are same. That means the water surface becomes in equilibrium after creating the tide. I hope you agree with that idea now. So let us go ahead, and here we can see that tractive forces are maximum at alpha equal to 45 degrees, where alpha is shown with respect to center of earth here, somewhere moon is here. If the higher tractive forces are there, although they are in equilibrium, but will create higher tides. Which force is stronger on the earth? So let us look into the ratio of the force. So if you take the ratio of the forces, let us say this is the force created by the sun and this is the force or acceleration created by the moon. If you take the ratio, you will get this expression. I can see that the force created by sun is proportional to the mass of the sun, but inversely proportional to the cube of the distance, and similarly for the moon. And if I take this data which is listed here about the radius of the earth and about the mass of the moon and sun here, So, this data, if I use this data and then I use this data, the distance, that is ds and that is dm. So, if I put this here, what will happen? I will get a ratio 0.46. You can try it yourself. So, what does it convey? It is conveying very important aspect, that the force exerted by the moon is more than 2 times of the force exerted by the sun, and that is why we say that tides are basically caused by the moon. One more aspect I would like to tell you here. So, water is accumulating here under the influence of tide and accumulating here, but what about this point? Water has been withdrawn from here towards this side and this side. So, these are the points of the low tide. Similarly, this point is point of low tide, here point of high tide, and here also we have high tide. So, it is sublunar point and it is antipodal point. Well, what about the forces here? It is 0 attractive forces, but still we have experiencing the high tide at both places. So, now you understand that there is a variation of the water surface of sea because of the moon's attraction. The moon rotates at its own axis in 24 hours and 50 minutes, and this is the solar hours. We can say almost 5 hours. So, what happens? Let us assume that moon is fixed and earth is rotating like this. So, I can see here that because of the rotation of the earth like this, one place on the surface of earth will face the moon 2 times in a day, or I can say 2 times in this 24 hours and 50 minutes, because let us say there are 1 point here, 2 point here. Earth rotates, let us say points are like this. So, if earth rotates like this, so after 12 hours and 25 minutes, this position will be here, which is away from the moon, and this position will be here. 12 hours and 50 minutes, this point will be coming here and it will be like this. So, during these 2 times, when the moon was here and this point was here, there was high tide here and high tide here. After 12 hours 25 minutes, again situation is same, high tide is again here and high tide is also here. So, in one day we experience 2 high tides at a place. Similarly, when this point is at 90 degree to the moon, there is low tide and low tide. When this becomes like that, low tide and low tide. So, we experience 2 high tides as well as 2 low tides in one day, or one tidal day, and tidal day is 24 hours 50 minutes. But you can see here that there is a high water here and there is a low water here, and this is the moon's position. So, it is high tide here, I can say high water. So, now we also observe the variations in the tide. Let us see, there is a moon and we have already resolved this problem, that there is high tide here and high tide here. What if moon is like this? What will happen? Although this is north south axis here and equator is like this point will experience high tide and this point will experience high tide, and these points are low tides points here, you can see, and this is, let us say, high tide and high tide here. Now, you can observe the same situation here. I am marking the equator by x dash and moon is there. What will happen? This is high tide here and this is the high tide here. What about the point z? If you see that point z is having high tide, this is parallel of latitude here, and z and z dash both are located at the same parallel of latitude. This is the tide level, which is quite low compared to this level. Now, you can understand that why do we have different tides within a day also, because points are away from the equator and moon is not located at the equator, it will create different tide levels at the same parallel of latitude. Similarly, if you look at the y position here, which is again on the same parallel of latitude, this is the tide level and this is the tide level. So, we know that y and y dash, they will be having high tide in a day, but at the same time they will be having different tide levels. So, what about the x position, which is at equator? You can see here, with respect to moon, with respect to this point, this has same tide, and with respect to this point, it has same tide. So, at equator the tide levels are same, but as we go away from equator for any given position of the moon, we experience the different level of the tides at the same parallel of latitude, because one point which is near to the antipodal or sublunar point will have higher tide, but the point which is quite away from the antipodal or sublunar point will have low tide. So that's the key here, that see the variation in the tide levels. Now we understand variations in the tide level. We also understand that there is a high tide and there is a low tide, and across the day we will feel two high tides and two low tides. But we also know that moon revolves or orbits around the earth. So what's the effect of that? There is eccentricity in the orbit of the moon. As a result, moon will be sometimes closer to the earth, sometimes little farther to the earth. And what we have said, ds and dm, they are the average distances. This is not the real distances. And because of that, this variation of the average distance and the real distance, we will have variation in the tides across the year also. So we'll see this now. What are the factors that affect the tides? I have written on this slide, so you can read it yourself and you can confirm this from the previous slide. There are two terms associated here. We have seen that moon and the sun both are exerting force on the surface of the earth, and moon is more effective because the distance and the mass. However, what if both of the moon's and the sun's force are exerting in the same direction on the surface of earth, and experience the highest tides? And that is shown here in this picture on the slide. This position is called new moon, when sun and moon are aligned in one line and they are basically above on this meridian of this point, and we see high tides here. Similarly, as we know, there will be high tide here also, and there will be lowest tide here also. And this phenomena is called the spring tide. It occurs at the new moon and full moon, and high tides are the common phenomena. One more thing I would like to write here, that the highest of the high tides are observed. There is another phenomena called neap tide, where sun and moon are at 90 degrees to each other with respect to the earth. What will happen? As we know that moon is more effective, so there will be high tide here and there will be high tide here. But you can see here that sun is less effective. We have low tide here and low tide here. But you can see both sun and moon are trying to attract the water surface in completely opposite direction or at 90 degree. So one is this vertical direction, one is horizontal direction on the screen. Now what will happen? We will experience the high tides in the direction of moon, and we will experience the low tides towards the sun. However, the height of the tide in the direction of moon will be much less than the highest tides or the spring tide. And I can see that this tide is, although high tide, it is the lowest of the high tides. So I can see the tides are lower than the average here. You can understand what is meaning. It is the lowest of the high tides. And that is called neap tide here. Now we understood why tides are coming, why the water level is raising, why there is a variation in the tide level, when we have maximum tide, when we have minimum tide, or the lowest tide or highest tide. At this stage, we should also know what is the frequency of the tide at a place on surface of earth. Here you can read it. The position of the moon at third and first quarter are creating the neap tides. There is another phenomena called priming and lagging. When the position of the moon is from the lowest tide towards the high tide, this is called the priming, and the position of the moon from the high tide to low tide is called lagging. These are the fixed terms here. What is the frequency of the tides? You can see the tidal potential which are causing the tides are modeled by series of harmonic function, because they are basically varying like sinusoidal form, or we can say some kind of periodic functions. We divide the harmonic coefficients into the three categories. One is semi-diurnal, that means 2 high and 2 low tides in each tidal day. Then diurnal, that is daily, that's single high and single low tides in each tidal day. Then we have long period. Long period means fortnightly, monthly, semi-annually, that is 6 months. Then 8.8 years, because eccentricity of the moon's orbit, Sometimes moon is closer, sometimes moon is away from the earth in its orbit. So then we have 18.6 years or 19 years if you remember the figure. That is because of the orbiting of the moon around the earth. Similarly, earth also revolves around the sun over a period of 20.9 years. That means the point will be exactly at the same position with respect to sun after 20.9 years or 21 years. But as we know that effect of the sun is much less than the moon, that is why we always prefer a period of 19 years for the observation of the tides. That means we create the MSL by observing the variation of the tides over a 19 years period at a place or at a sea coast. I hope that you got the idea why do we go for technical analysis for the tides. So now let's understand what is the necessity of the hydrographic surveys. Well, we have said that tide is going to increase the water level, tide is going to decrease the water level than the average value, but I want to measure the depth at each and every location. What's the reason? The reason is that we want to expand the offshore and shipping industry, and if I construct some structure over some sea coast, I need to have data of hydrographic survey. What is the material available or what is the material has to be cut from the available surface. Then we have to locate resources like oil and gas wells in the sea offshore sites. For that also I need to bring boat or the staff members for the drilling, and for that purpose we also need this data of hydrographic survey. Then we also see the supporting material has to be provided, sea and river navigation, and then recreational purposes. What are the recreations? If you go to some place like Goa, near the sea, there are some scooters moving in the water and they are available on rent. For such kind of recreational facility also, we have to have the information about the tide as well as information about the 3D data of the surface bed of the water body. So what are the objectives here? First of all, I want to measure the tides. Then I want to determine what are the shorelines. Then what is the wet depth? What is the current velocity and direction of current in case of rivers? What is the amount of flow? Because for the river navigation, these factors are very important. What are the scouring and silting? And shoals? Shoals are the submerged ridges and banks of unconsolidated material. That means they keep on moving with the flow of water. When there is high tide in the sea, traction forces or tractive forces are bringing the water at one place and again they are withdrawing the water. Because of that movement, there will be a movement of the shoals. So I want to determine those. Then what are the places where light rocks and bayous are there? How to plan the hydrographic surveys? First of all, we go for the reconnaissance survey. We should know what is the area of the survey, which is like say kilometer square, and then platforms available like we have ships, aircraft or vessels. Then whether it's a short term or long term survey. Long term means I will collect the data after a certain period which is quite long, and short term means I am frequently taking the data. Then other limiting factors like budgets, political reasons, geographic or operational constraints and logistics are factors we should consider in planning part of the hydrographic survey. Now in case of hydrographic survey, observe the 3D information or measure the 3D information. So we have to establish the control surveys. So first is vertical control. So what is vertical control? From the topographic data, we have some data available about the benchmarks. So using those benchmarks, we bring the control stations very close to the sea surface or shoreline. We'll see all these terminologies in the next lecture, but now try to understand what's the concept here. Then using those benchmarks, and we establish the levels of the seabed. So that is vertical control. Similar to the vertical control, I bring the points of the horizontal control, that is the X and Y position from the topographic survey near to the sea coast, establish some control stations, and this process is called the horizontal control. And using horizontal control, we determine what is the horizontal position of the point which is lying under the water, but we measure it from the surface of the water. You can understand that planimetric position xy is measured on the surface of the earth, and at the same time we measure the depth of the water by some mechanism. So we need to separate the two surveys, but still it is not a pseudo survey because we are measuring x, y and z at the same time. Moreover, we are considering the curvature of the earth also. We are no more projecting the earth on the plane. So it is not a pseudo 3D survey, it is a perfect 3D survey. We measure the xy on the water surface. Also we measure the depth of the seabed on the water surface, but we need to have different instruments for that purpose, because I cannot measure the depth of the water using the conventional instrument like theodolite, total station and so on. I need to have some different instrument, and for that purpose we separate the planimetric survey and the vertical survey in case of hydrography. I hope that you got the idea here. So what do we do? Basically we take a vessel, draw the vessel along a straight line. On this straight line we observe the points at regular interval, a regular time interval or regular distance interval. So this is shown here. You can see here, because of the variation in the current velocity, we are having lines which are not straight, but still we are trying to maintain them. These are the data points collected at a regular interval on each line, and these are the lines or the track of the vessel or boat. You can see here average distance between the two lines. So that's a good way to mark here. This is line spacing, this is the line spacing, this is the line spacing, and so on. So line spacing decides the density of the data points. We'll see in coming lectures that line spacing decides the time interval to cover the whole area. That means the duration of survey. Indirectly it is giving the cost of my survey. The higher the data density, higher the cost. Higher the data acquisition time, higher the cost. So what are the factors that affect line spacing? One is the scale of the survey. As I told, if I have higher density of data points or higher accuracy of the data points, definitely line spacing should be smaller. What about the orientation of the shorelines in the area? Right now we assume that the shoreline is like this, and that's why we are starting from this point, starting point, and this end point here. So we're starting from shoreline with the boat here, and we are finishing our survey here at end point. So this orientation of the shoreline, that also decides the line spacing. Now the DTM, so DTM requires the sufficient data density to draw the correct contours. That means I need to have more amount of data, at the same time I need to have more accurate data. That means each and every point should be more accurate for smaller contour interval. These are cross check lines, or they are sometimes called tie lines. You can see here these lines are the cross check lines. These are main survey lines that we have already discussed in last slide. Then after doing this survey and after collecting the points on these black dots, what do? We try to validate our work by collecting some points on these lines which are perpendicular to the survey lines, and this validate work. Similarly, if survey lines are vertical on the screen, these are cross lines. So I am collecting data over there to validate work. Similarly, if I have two type of survey lines, horizontal, vertical, so I will have two type of cross lines like this. You got the idea that how do we validate our work? So what are the equipments required? Buoys and shore signals. That means there are some signals which are floating in the water and where we measure our XY position as well as depth. So these are called buoys. For the angle measurement, we have theodolite and total station. With the total station, we can measure the distance as well as angle. And then we have sounding equipments. These are sounding equipment, lead line and the sounding pole. And also we have sounding equipment like echo sounders. What are the lead lines and sounding pole? Basically these two instruments are used to measure the depth of the seabed or river bed. We will see all this as we proceed in this lecture. Now we are considering some of the methods to introduce you how to do the measurement of the depth. So first is lead line method. Here there is a graduated rope. With the help of some heavy weight, 5 to 10 kgs, I am suspending that at a position where buoys are located. So buoys are floating on the water surface. I bring the boat there, stop there and try to suspend the lead line. So lead line having a heavy weight at the end, it will keep on lowering down itself under its self weight, and when it touches the seabed or river bed, I will stop and I will measure the height. Since it is a graduated one and having the 0 mark on the bottom, the point which is closer in my hand of the rope, it will indicate the depth. That's a simple idea here. So it is also shown here in the figure. Second is sounding pole method. So instead of rope, I am using a sounding pole which is 5 to 8 meter length and it is having 5 to 10 centimeter diameter. I am again approaching the buoys. The moment I reach to buoy at the XY location or at the position of buoys, I will drop down a sounding pole vertically. I assume here that there is no water current, so water is still very calm, and as a result, whatever depth of the water is there, that will be indicated by the sounding pole, and sounding pole at the time of measurement, it touches the riverbed or seabed. As I know that it is only 5 to 8 meter in height or length, we can conduct the hydrographic surveys with this sounding pole if the depths are in this order. So these are the idea, and the key point here is that the 0 point is always marked at the bottom where the sounding pole or the lead line touches the riverbed. This wire drag survey. In case of sea or in case of big water bodies, we have two vessels. Let us see, there is one vessel here and there is a water surface, and let us say there is water bed. There is a wire being stretched between the two here. On this wire we have some buoys, and then we try to suspend some heavy weights like this. These are heavy weights here, and we suspend another one here like this, and they are also connected here. Similarly, we keep on doing this. Now let us say there is some obstruction like this on the water surface. That means the riverbed or the seabed is like this. That is, here this is seabed and seabed is here like this. What will happen the moment we suspend the wire here? It will interact here at this less height. As two ships moves, the catenary or the straight length of the wire drag will be made like this, and there will be V shape here at this point. Now we can understand that there is some obstruction on the seabed or riverbed. So I can find out by putting this correction what is the seabed depth here. That is the idea of the wire drag survey. We have the fathometers, or what we call echo sounders. Originally they are named fathometers, and nowadays we are using the term echo sounder. It basically sends sound waves into water, and that sound waves interact with the surface of the seabed or the riverbed, and it reflects back the energy of the sound, and again it is collected by the instrument. By measuring the travel time of to and fro distance, we measure the time of travel, and using that time of travel we determine the depth of the seabed or riverbed. So that is the idea of the fathometer. Then we have single beam echo sounder. It throws the sound pulses vertically down towards the surface. Then we have multi-beam echo sounder, which throws pulses in across track manner like LIDAR. In case of radar, we have the same mechanism, what we call a whisk broom mechanism. So according to whisk broom mechanism, that multi-beam echo sounder is throwing pulses in this direction like this: 1, 2, 3, 4, 5, 6, 7, and again as we move 1, 2, 3, 4, 5, 6, 7, and so on. So the multi-beam echo sounder is throwing the pulses towards the seabed, and it is acquiring the data in the zigzag fashion. We can see here that all the methods what we have discussed, like sounding pole, sounding line, the lead line or the echo sounder, all of them are little time consuming because their coverage is very less. But at the same time we realize that there are some pulses like sound pulse or the laser pulse, they can penetrate through water, and as a result we want to use them. What if I use the airborne facility? That means there is a LIDAR sensor that is throwing the pulses towards the water surface, and as a result there are two types of pulses. One is red pulse here that is interacting with the surface of the water and it's reflected back. On the other hand, there is another type of pulse which is green pulse that is penetrating the water, interacting with the riverbed here and going back. It is reflecting also, but again it is reflected back and it is going back to the sensor. And by measuring the time interval of the green and the red pulses, I can find out what is the depth of seabed, and the coverage will be much higher compared to the echo sounder which is used with the vessels. That's the idea here about the measurement of the depth. So we will be discussing all the instruments in detail in coming lectures, but here we are giving an introduction that how do we perform hydrographic survey. So as we realize that we need to collect the data by hydrographic survey, first we should understand that it is a different kind of survey compared to the topographic survey. So we have the different standards, and that's why we should first understand those standards, and then we should try to think that what is the quantity of work and what is the kind of work we need to conduct when we talk about hydrographic survey. So, we have two kinds of standards. One is international standards, that is decided by the International Hydrographic Organization (IHO), and that is basically governed by the International Hydrographic Bureau (IHB). And then we have the country specific standards. For example, India, there is a Bureau of Indian Standards. They have developed a code IS 4651 which discusses about the standards for India. At the same time, we have the Canadian Hydrographic Services for the Canada. Now we are going to discuss about the IHO standards and the BIS standards in this lecture. We are discussing the country specific code. At the same time, we are discussing the provisions in the international standards. So, let us talk about the IHO standards first. It divides area to be surveyed according to the importance. It has 4 orders. One is special order, then we have order 1, order 2 and order 3 surveys. Order 3 surveys are for the water depth more than 200 meter, order 2 for less than 200 meter, order 1 is less than 100 meter water depth. Again, it has some other specifications according to 100 meter, 200 meter and 300 meter. That means for 100 meter or order 1 survey, we have less hazardous bottom, more clearances, harbour and general intercoastal and inland navigation channels. Now, what about the special order? We define a term minimum under keel clearance. That means because of the weight of the vessel submerges partly into the water. So, after submergence from the bottom of vessel to the riverbed, there should be some minimum distance, and that is called the mean under keel clearance. So, in case of special order survey, we try to determine what is the mean under keel clearance, is it available or not for a given water vessel or for a given ship under the some loading conditions. Here we are looking for potentially hazardous bottom characteristics, whether there is some underwater permanent body at a given point or any other obstructions, and that is why we say that we should have the closely spaced survey lines, or we say that whatever we do, we should cover the 100% bottom search, and that is called the special order survey. I hope you got the idea that why do we need special order survey, order 1 survey, order 2 survey and order 3 survey for hydrographic survey practices. And this is the specifications of the International Hydrographic Organization. We want to discuss about the positioning also. We determine the sounding, which is nothing but depth. At the same time, we determine the XY position where we are determining the sounding. Now, imagine that I am using a sounding instrument which is quite accurate, but if there is no accuracy of position XY, then there is no point of having the higher accuracy of the sounding instrument, and that is why we need to specify the accuracy of the horizontal positions also. That is why we define that with the 95% probability, 2 positions should lie within the given accuracy level of horizontal position. Nowadays, in the latest version of IHO, specified that we should also consider the depth of the water to define the horizontal accuracy. That means, if higher the depth, I can have some tolerance on the horizontal accuracy of position. For special order, there is no compromise. That means each and every point XY should be located within 2 meter accuracy. That is coming from 95% confidence interval. We have already discussed these 95% criteria, adjustment computations or in the basic surveying. Next is order 1 survey. What is this? It is 5 meter plus 5% of the depth. That means if the depth is, let us say, 40 meters, now we say that the order 1 survey has to conduct for the depth below 100 meters. So, yes, 40 meter is appropriate for order 1 survey. If you take the 5% of the 40 meter, that will be how much? 40 into 0.05, it is equal to, you can see here, okay. Then we can see like this. So, now we can have 2 meter additional one. So, we have 2 meter additional tolerance in case of order 1 survey. Similarly, for order 2 survey, we have 20 meter plus 5% of the depth, and for order 3 we have 150 meter plus 5% of the depth. So, this is the way we calculate the possible accuracy level for a given depth. You can see here, if I measure the depth with high accuracy, I can comment that what is the tolerance of planimetric position, or what is the tolerance of accuracy of the planimetric position. One more thing is there, the depth accuracy. So, we talked about the position accuracy, now we are talking about the depth accuracy. Again, we have defined the 95% confidence interval level, and fixed errors and depth dependent errors should be included here. Finally, how to determine the errors or the accuracy. So, it is a square plus b into d times whole square, where a is constant error. So, if I make the sum of all the constant errors, which is equal to a here, and b is depth dependent error. We said in case of position error 5% of the depth. So, it is somehow b is like that factor, b into d, then we will make the square and we make summation of the squares, and then we take the square root. This is depth accuracy. So, we should be very careful to evaluate the depth accuracy of the sounding operation. Then if we have systematic errors and random errors, we should make the use of this formula. This is systematic error square, random error square, and then we use this RMSE logic. What about the line spacing? In case of special order, we have 100% bottom search, which is essential that whatever accuracy we maintain or whatever line spacing we maintain in case of special order survey, I have to have exploration of 100% bottom. That means complete seabed or riverbed has to be checked. In case of order 1, we have 3 times average depth or 25 meters. In case of order 2, we have 3 to 4 times of the average water depth or 200 meter, whichever is greater. And then we have order 3, which says 4 times of the water depth. The line spacing is shown here, and it is wider line spacing here. So, these line spacings are decided according to this survey order criteria. So, we should minimize systematic and random errors, that is quality control. And then what is the quality assurance? I should validate accuracies also, that is called the quality assurance. Coming to the Indian standards, which are governed by the Bureau of Indian Standards. Accuracy requirement is according to the purpose of this survey. So, for the structural installations, dredge quantity estimation, we should have a special order survey, and special order survey are according to the IS standard, not the IHS standard. So, then general planning, pipeline route selection, we have order 2 survey, and then we have order 2 survey for the numerical model input purpose. How to decide the line spacing? For the single beam echo sounder structural installation, we have 10 meter line spacing. Then for the pipeline route selection, 50 meter. Again, for numerical model and input processes, we have 100 meter line spacing. We should also prepare the hydrographic charts for the detailed planning, and to do the general planning, we should have a map of 1:50,000 with a contour interval of 20 meter. For the detailed planning, we should have a map scale of 1:5,000 or 1:2500 or 1:250 also, very high level contour 1 meter. The accuracy standards are to be followed as per the IHB publication. Then the spacing between the tie lines or the cross lines in traverse direction should not be more than 10 meter. Here is very special thing about the cross check lines, be careful on this. And line spacing requires 100% overlap between the swath of adjacent path for multi-beam echo sounders. That means, if I am using a multi-beam echo sounder for very special purpose surveys, then I should have the complete coverage of seabed. So, single beam echo sounder are to be considered for shallow water depth. That means, if water depth is less than 10 meter, I can use the single beam echo sounders. In addition to that, the Indian standards also specify meteorological data, oceanic data, geological data to be collected as per this standard. So, once we collect the hydrographic data by hydrographic survey, what do we do with data? We develop the nautical chart. So, what is nautical chart? Nautical chart specifies obstructions in the water and channel markers, and it uses different colors and numbers. Let us see, this is nautical chart. The beach or 10 color here indicates the land masses or obstructions. This is land mass, or it could be the shoreline or some kind of land surface. If we have dot with a teardrop, it indicates lighthouses. So, this is the location of the lighthouse. Then we have white for deep water, and we have light blue for shoals or shallow water, like this. This is shoal, and the remaining white part is deep water. You can see here shoals. Then we indicate numbers to indicate the water depths. So, these are numbers indicating the water depth. You can see that here some depth of unit 13. What next? We have the unlighted green and red bios, that is small diamond shapes of the appropriate color. So, these are small diamonds, that means the red is indicating the red color bios and the green is indicating the green color bios. The circle surrounding the bio depicts that it is floating. That means if I draw the circles like that, it means that both green and the red bios are floating on the surface of water. Then we have bios like that, which we are showing with a color here, the filled color, filled circle. They are indicating that they have some electricity light and they are flashing. Now we have some other features also like wrecks and sudden wrecks indicating danger to the navigation. So, like this. So, then we indicate rock awash, coral reefs which have unknown heights like this. And then there is another expression of the hydrographic survey data, which is hypsometric curve, especially for the sea. What is the hypsometric curve? It is the scientific way of describing the topography of the sea floor. It denotes the percentage of the earth's surface at various ranges of elevation. That means if I draw an elevation level, that how much area is above that level on the land as well as above the land in the sea. The cumulative hypsographic curve gives the percentage of the surface area from the highest peaks to the deepest depth of the sea, river, ocean bed. It's kind of elevation curve it is giving, and this is giving that where the sea depth and what is the depth, but it's very low scale curve. The curve displays the elevation on y-axis and the vertical area above the corresponding elevation of x-axis. The curved line on the graph gives the different type of material present. This is an example that we have taken from the website of NOAA, and here we can see that this is the water here. This curve is showing the surface level of the sea floor on the land as well as under the sea. So, this is continental plain and this is sea here. So, here is sea depth. That's 0 level. So, as we go along here by unit of 10, 20, 30 and so on, I am having at this elevation level, for example, at 4000, minus 4000. So, this is the water level and this is sea level. So, I am saying 0 level, and again I am indicating what is the average ocean depth here. So, this is elevation level here and this is the cumulative area of earth's surface. So, as we are going in the x direction, the cumulative area is 10, 20, 30, 40 and so on. And here we are showing the histogram, what is the area like this under water and so on. So, that is what we call hypsometric curve. And what are these applications? Isostasy, continental ocean crust related to the geological studies, but they also come from the hydrographic data. And that is why we say that we have two products, one is nautical chart and other is hypsometric curve. So, with this we say that we are now close to the end of our lecture 1 on introduction and the fundamental concepts of the hydrographic survey. I hope that you could understand why do we do the hydrographic survey, what are the tides, what is low tide, high tide, what is the frequency of the tide, how tide varies, how the attractive forces are accumulating the water on one point on the surface of earth and creating the high tides and low tides. With this we realize that how hydrographic surveys are very important for river as well as for the sea. In case of river, we have the river navigation. In case of sea, we have navigation as well as tide phenomena. At the end, we understand that what are the standards and we should follow those standards. We realize if we collect the data, we have two products that can be prepared. One is hypsometric curve and other is nautical charts. I hope you got the idea of the hydrographic survey. We would like to highlight that we have used these documents to prepare our lecture, some of the sources for our images. In the next lecture, we will be talking about the field procedures, that means how to collect the data in hydrographic survey. Thank you.